this implicit differentiation because I know that it is hard. Okay, I just know it is, and so I know you need more examples. So we're going to do more examples, and there's a whole new assignment. And know that on any of these, you can do more than I require. Okay, so like I might require 3 of them. You can do 8 of the questions if you want to. You don't have to stop at what I just require. That's just what I ask you to do. So if you need more practice, you can get it yourself. Okay, so implicit differentiation. Again, we're finding this derivative dy dx, and remember that's the same thing as y prime. We're finding y prime in terms of x and y. Now, if I read this one out loud, this equation right in there, I'm going to read the word times. If I read this out loud, it would be negative x times y plus 3y equals 3. That word times should signify that you're going to have to use the product rule. You should know, oh crap, I'm going to use the product rule anytime you say times. So reading it out loud is not a bad thing to do. It's not bad to kind of think, well, if I read it out loud, am I saying the word times? If you are, that's product rule. If you say the word of, that's chain rule. So think about that as you're reading these. But if I'm doing this problem right here, I'm going to do the product rule on this. So I'm going to take the derivative of x, negative x, so I'm going to have negative 1 times y plus negative x, and now the derivative of y is y prime, plus 3 is a constant, the derivative of y is y prime, equals 0, because the derivative of 3 is 0. Now, all I'm doing from here is solving this for y prime. So if I move the negative 1y over to the other side using algebra, this would just be y. If I add y to both sides, if I factor out a y prime, this is negative x plus 3 equals y. So y prime is equal to y over negative x plus 3, and you're done. So there's an example when we use the product rule. Let's take a look at this one. Another one. If I read this, this is 3x cubed minus 5 minus 2y cubed equals x times y. Right there, you know, you just said out loud when you read it, you said the word times. If you say the word times, you should know product rule. We have to use the product rule. We said the word times. We know we need to use the product rule on this. Okay, so if we're going to do this problem and we use the product rule, again, remember when we take the derivative of y, we're going to need that y prime. So if we take the derivative of 3x cubed, that's 9x squared. The derivative of minus 5 is 0. I'm going to write it. I know you don't need to, but I just wanted to see, didn't want you to go, well, where did the 5 go? It's 0. The derivative of minus 2y cubed is negative 6y squared times y prime. Okay, again, I'm differentiating y, so I need that y prime. I'm differentiating the cubed, that's why I need to do that first part. Equals 1 times y plus x times y prime. Because again, I'm using the product rule on the right side. Now, I have something that all I need to do is solve for this variable y prime. So I'm going to move all the y prime stuff over to the left side, and I'll move everything that doesn't have a y prime over to the right side. So the minus 6y squared times y prime stays. I move the x times y prime over. And on the other side, I have y minus 9x squared if I move the 9x squared over. The next thing I'm going to do is factor out a y prime. If I do that, this is minus 6y squared minus x equals y minus 9x squared. And then finally, I'm just going to divide so I have all my stuff separated from y prime, and that is y prime. That is the derivative. You know, if you really wanted to, you could say, oh, well, this is the derivative. This is dy dx. That's what y prime is. So if you wanted to use that notation to get back to the notation that we started with, you could certainly get back to that notation and finish it off that way. Okay. Let's take something like this. Now, I want you to think about reading this out loud. If I read this thing out loud, it would be given the sign of x times y cubed equals y. So, couple things on this that I need you to pay attention to. Number one, right in here, the word of is said. That's a chain rule. Right in here, the word times is said. That is a product rule. So we can use both of these rules. So you think about how I read this out loud. The sign of the quantity x times y cubed equals y. So I'm going to use the product rule and the chain rule on this all at once. It's going to be messy. Don't freak out. We're just going to get through it. So don't freak out. I'm going to change to a little smaller, thinner line. But here's what I got. So leave that right there. So derivative of sine, cosine. I leave the xy cube alone because that is the inside. Now I'm going to take the derivative of the x times y cubed. So I take the derivative of x, which is 1, leave y cubed alone. Because it's the product rule, I add x times 3y squared times y prime equals y prime. There is my derivative. You might go, oh my God, that looks terrible. And I would say, yeah, that looks pretty bad. But we can simplify this. We can simplify this by actually taking this thing and distributing it to that term and to this whole term. If I do that, I'm going to write this as y cubed cosine x y cubed plus x 3y squared y prime cosine x y cubed equals y prime. We're doing the same process that we did before. We're getting the y prime all by itself on the left side and everything else on the right side. So what I'm going to do is I'm going to leave anything with y prime on this side. So that stays. I subtract y prime that was on the right side, and I get rid of the term that doesn't have a y prime that's on the left side. Get rid of it by moving it to the right side. Now, if you notice on the left side, we have a factor of y prime that we can factor out, just like we did in the last problem. If we factor out a y prime, this is still x 3y squared cosine xy cubed minus 1 equals negative y cubed cosine xy cubed. And the negative 1 is there because if I distribute the y prime, I would get back to where it was before. Now, all I need to do is divide by that whole mess that's attached to y prime. And y prime, which is dy dx, is equal to negative y cubed cosine of xy cubed. Get rid of that. Let me make that better. All divided by x is 3y squared cosine xy cubed minus 1. And that's it. It started out as a messy equation. It's got to finish as a messy equation. So don't worry about it. It's messy. Who cares? It's done. Okay, you can pause the video and you try this one. You give it a try. All right, hopefully you're back, and I'm going to walk you through this one. If I walk you through this one, right here, that's of cosine of quantity x cubed times y cubed equals y. Okay, so we can do this. This isn't so bad. Negative sine x cubed y cubed times 3x squared y cubed plus x cubed times 3y squared times y prime, because I differentiated y on that one, equals y prime. Now this problem is actually the exact same problem as we had before. We just have to get all this stuff together. So I'm just going to do everything that I need to do. So if I distribute this whole thing through to here and through to here, and I'm just going to write it as negative. Actually, I worry about if I don't write these things first. So this first term is negative 3x cubed y cubed sine x cubed y cubed minus, and I'm going to rearrange this just a little bit, y prime 3x cubed y squared sine x cubed y cubed equals y prime. So all I did is I just distributed that negative sign through. That's where those negatives showed up there. And I did do a rearranging because I can, because it's all multiplication. Everything in here, in between those things, is no multiplication, so we can rearrange them. Now I'm going to move the y prime from the right side over to the left side. Leave everything else alone. 3x cubed y squared sine x cubed y cubed minus y prime equals 3x cubed y cubed sine x cubed y cubed. Yeah, typing this into Delta Math could be a challenge for you. I am going to factor out a y prime. And rewrite everything else. Hopefully I wrote it right. The next thing I'm going to do is divide, and I am done. Y prime is equal to 3x cubed, y cubed, sine, should that be y cubed? I feel like that should be y, oh, shoot. make these changes. You hopefully saw these. I just didn't write them right. That's why this is going to be challenging to you and to me, apparently. Oh, I hope I didn't mess that up. Doggone it. I am going to start this over because I think I messed it up. And that's why you have extra paper. So maybe you saw my mistake and you can just fix yours. So I'm going to start this over. Okay, here we go. Derivative of cosine is negative sine x cubed y cubed times 3x squared, that was one of my mistakes, y cubed plus plus x cubed times 3y squared times y prime equals y prime. There, I know that's right now. Now I'm going to simplify, and I'm not going to do my fancy moving things around like I did last time. So I'm going to have distribute this through to here, through to there, and I'm going to have negative sine x cubed y cubed times 3x squared y cubed minus sine x cubed y cubed times x cubed 3y squared y prime equals y prime. Now I'm going to move the y prime over, move the other thing over to the other side. So negative sine x cubed y cubed times x cubed times 3y squared times y prime minus y prime from the other side equals, now this is going to be a positive term. Now I got that term. Now I'm going to factor out a y prime and leave everything else just the way it is because I screwed up last time when I started to rearrange things. And once I write this down, you're going to go, why do I have to write that down? Because I'm just going to end up dividing. And I would say, you're exactly right. And if you can skip these steps, anything, that would be fine. But now my final step is just dividing by that missing piece, or that piece. You're going to need to make sure you put parentheses around that sine x cubed y cubed. And then we're going to divide by negative sine x cubed y cubed, close a parenthesis, times x cubed times 3y squared minus 1, and now I'm done. And that was a mess. And I understand that was a mess. All right. Find the equation of the tangent line. Oh boy, I got two more problems. Find the equation of the tangent line to this curve. So this is going to be a challenging one. We're going to I'm actually going to stop this and make a new video for these last two examples.